Hello everyone, welcome to iQuanta. Let's discuss another question from this amazing series of Quant 200. And before you start watching the solution, try it yourself. This question, it says the total number of factors of an 8-digit number pqrs is n, where n is a natural number. Find the sum of all the possible values of n if it is given that pqrs, a 4-digit number, has 3 factors. pqrs is a 4-digit number, right? So, for example, if we have 123, can we write it as 100 plus 23? Then we have 7928. Can we write it as 7 into 1000 plus 928? If we have 92728, then we can write it as 92 into 1000 plus 728 and so on. So just understanding this, can we write pqrs as 10,000 into pqrs plus pqrs? Then we can take pqrs common and this will become 10,000 plus 1, which is nothing but pqrs into 10,001. Now you can also find this factorization very easily if you are aware of some calculations in case of numbers, that if you have a single digit number, let's say a, and you multiply it by 11, this digit will be repeated, a and a, like 2 into 11 is 22. Then if you have a 2-digit number ab, if you multiply it by 101, it will be ab. Like if you multiply 35 by 101, what are we getting? 3535. Similarly, if you have a 3-digit number abc and you multiply it by 1001, then this 3-digit number will repeat itself. Similarly, if you have 4-digit number pqrs, then what we can say, that one of the factors of this number is 10,001 and then pqrs. Now what is 10,001? Again, it's a very popular number in terms of factorization. This can be written as 73 into 137. Now it says it is given that pqrs has 3 factors. pqrs has 3 factors. What is that? Which kind of numbers has 3 factors? Right? So if you want to check the pattern, let's say 4. 4 is a perfect square, 2 square, and it has factors 1, 2, and 4, 3 factors. Let's say 9. 9 is also a perfect square. 1, 3, 9. It has 3 factors. Then 16 is also a perfect square. But 16 is 1, 2, 4, 8, and 16. 5 factors. So not all the perfect squares have 3 factors. So what kind of perfect squares have 3 factors? A number which can be written as prime number square, right? Any number which can be written as a square of a prime number will have exactly 3 factors. Like 11 square, 121, 13 square, 169, 19 square, 361. All of these numbers will have 3-digit, 3 factors. So basically, pqrs is nothing but prime number square into 73 into 137. Now once again, pqrs is a 4-digit number, right? And the smallest prime number whose square is a 4-digit number, if you think it will be 37, right? Because 31 square is 961, 32 square is 1024. So after that, prime number 37. And what is 37 square? That is equal to 6, 9, 25 minus 13 is 12 plus 1. 136. This is a perfect square. 1369 is a perfect square. And it will have exactly 3 factors. Then we can also take 41 square. Then we can take 43 square. Similarly, somewhere in between, 73 square will also be a value of PQRS, and last it will be 97 square. All of these will be a 4-digit number and a perfect square, which will have exactly 3 factors, right? So what we can say, what will be the number of factors of this number? So there will be 2 different kind of scenarios. One of the case will be when we have this prime number as any number except 73. Let's say 37 squared. So 37 into 73 to the power 1 into 137. What will be number of factors of this number? So 37 square will have 3 factors. 73 to the power 1 will have 2 factors. And 137 to the power 1 will have 2 factors as well, because 137 is also a prime number. So a total of 12 factors. Means this is one of the possible value of n. Now, can we take 73 as the other prime number? Now, instead of 37, it could be any prime number, 41, 43, 97. It will have the same number of factors. But if I take this pqrs as 73 square, then what will happen? Then we need to find number of factors of 73 to the power 3 into 137 to the power 1. Now 73 to the power 3 number of factors is 4 and 137 to the power 1 number of factors is 2. So total 8 factors. Now it says that total number of factors of this number is n. So n can take 2 different values. One value will be 12, another will be 20. So the sum of all the values of n that we are looking for is 12 plus 8, that is equal to 20, and that will be our answer. So option B is correct. I hope you understood the solution. Thank you.